So this is a geometric sequences sum part 2. In the previous lesson I'd gone over finite sequences and finding their sum. So this one's more about infinite sequences. Again, so geometric sequences that really last forever, going to infinity. So there's no defined boundary, there's no defined range of terms that we're really looking at. It's just infinite. So you could say that as we're finding the infinite sum here. It's obviously like the when we were looking at finite geometric sequences, there was this different formula that we were looking upon. So now here there's again a different formula. This one's much more straightforward. So it just states that to find the sum is equal to a1 divided by 1 minus r. That's the formula that you really want to know if you see an infinite sequence. And so, really, you could have anything. For instance, say you have something like, I don't know, you have something like infinity here, and then you have n is equal to 1 here, 4, 0.6 to the power of n minus 1. Now, if you look at this, obviously you know that this is an infinite sequence because the fact that your upper value here is infinity, it shows that this is an infinite sequence that we're looking at. And so this is obviously our sequence. And so here we're really just plugging in these values here. So we again want to find the first term, a1, and the common ratio. Now the first term here is obviously, we know that n is equal to 1 is where the sequence starts from. So if we do this, n is equal to 1, 0.6 to the power of 0 is just 1, times 4 is 4. Therefore A1 is 4. And your r is 0.6 again, because this is an exponential function. Therefore, the base of this, the base here of this exponent here, 0.6, that is the common ratio. So that's 1 minus 0.6, and so 1 minus 0.6 is 0.4 here, and so 4, and then obviously we would do the reciprocal here. So we get that the sum is actually 10. So our sum here would be 10. So for this specific problem, the sum of this geometric sequence here is 10. And if you think about it, it would make sense, because really as your n value increases, right, you take a larger n value, your overall value is gonna become smaller. Why? Because your r value, your common ratio, is less than 1. So if you have 0.6 to the power of, I don't know, to the power of 1,000 or to the power of 2,000, that's giving you a really negligible or a really small value. And so overall, that effect probably ends up giving you 9.99999, something like that. And so your overall answer is 10. Now this formula is applicable when you know that r, the absolute value of r, is less than 1. And this is important to understand. If your common ratio value is 3, right? If it's 3, and if it's a positive common ratio, that indicates that it's obviously increasing. It's obviously your sequence is increasing in an exponential method, or more, it's increasing exponentially, and so your overall answer in that case would be infinity. Now if your common ratio is smaller, right, or it could possibly be negative or something like that, then you would you wouldn't see a negative infinity as much as you would see a positive infinity. That's a little bit more complex. So we're really looking more towards infinity. So if you see something like your common ratio being 5 or 5.5 or 6, and you have a sequence starting from n is equal to 1, or really anything all the way till infinity, your answer in that case would be infinity, because you don't have a fraction. If you have a fraction, if you have something that's less than 1, then obviously it makes sense that your value is not going to be exponentially increasing, because as I said before, if you have a decimal raised to an exponent, then your value actually decreases if you increase the exponent. So 0.6 to the power of 10 is much smaller, therefore your value will not be going to infinity. But if you have something like, for instance, let me just say, if you have something like 4, and then we have like 5 to the power of n minus 1, and then they ask what this is, clearly your answer here would be infinity. And the reason is, take anything, take 4 minus 1, and then you're gonna get a larger value. You're gonna get 1,000 each time, and your end value is increasing till infinity, and your overall summation will also be approaching, or is actually infinity. But obviously, if your common ratio is less than 1, then you use this formula: S is equal to A1 divided by 1 minus R. So thanks for watching.